Ever pondered on the question, why does an apple fall from the tree and not go up? This seemingly simple query sparked Sir Isaac Newton's discovery of gravity, laying a cornerstone for physics. As we dive into the realm of physics problem solving, we're essentially trying to comprehend the laws of nature and apply them. We're learning to speak the language of the cosmos, to decode the secrets of the universe. To master physics problem solving, one must follow a methodical approach. The first step in any problem solving process is to comprehend the problem. So let's delve into the heart of understanding physics problems. It starts with a thorough reading, soaking in every detail. This isn't your average novel where you can skip lines. Every word in a physics problem could be a clue, a piece of the puzzle that leads to the solution. Once you've read the problem, it's time to dissect it. Identify what's known and what's unknown. The known quantities are your tools, your allies in this journey. The unknowns, they're your destination. Next, consider the physical laws that might come into play. These laws are like the rules of the game. You need to know them inside out to understand how to use them to your advantage. Is it Newton's laws, the laws of thermodynamics, or perhaps quantum mechanics? Your understanding of these laws will guide your steps towards the solution. Remember, a problem well understood is a problem half solved. Once you understand the problem, it's time to chalk out a plan. This is where your knowledge of physics concepts comes into play. Your plan should be a step-by-step guide to navigate the problem. Start by drawing diagrams. These visual aids help you understand the problem better and identify the physics principles involved. Next, jot down the relevant equations. Remember, physics is a language spoken through equations. Identify and write down the equations that connect the known quantities to the unknowns. Then it's time for calculations. Use the equations to compute the unknown quantities. Be meticulous and precise to avoid errors. Yet, the key to a successful plan isn't just about calculations and equations. It's about thinking logically and systematically. Think of your plan as a roadmap. It should guide your thoughts and actions towards the solution. And there you have it. With a solid plan in place, you're ready to tackle the problem head on. Execution is where the rubber meets the road. At this stage, you've got your plan laid out and it's time to put it into action. This is where you start to see the fruits of your labor, but it's also where you need to be most vigilant. Remember, physics problem solving is a delicate process, much like baking a cake. You've got your recipe and you've laid out your ingredients, but now you must follow each step carefully. Measure accurately, mix thoroughly, and be patient. As you carry out each step of your plan, ensure that you check for accuracy. This is your safety net. If something doesn't seem right, don't panic. This is where your understanding of the problem and your plan come into play. Troubleshoot, adjust, and carry on. Remember, the goal here isn't just to find the solution, but to understand the journey to it. So take your time, be thorough, and enjoy the process. Execution is where your planning pays off, leading you closer to the solution. The final step in the problem-solving process is to review the solution. The essence of this step lies in verifying your answers for accuracy and consistency with the laws of physics. It's about ensuring that your solution makes sense both mathematically and physically. Now, don't just stop at checking your calculations. Interpret your solution in the context of the original problem. Does it answer the question posed? Does it align with the known principles of physics? These are the questions you need to ask yourself. And here's the most important part, learning from your mistakes. If you find a discrepancy, trace it back. Find out where you went wrong. Was it a calculation error or a conceptual misunderstanding? Once you identify the error, work on correcting it. Remember, every mistake is a learning opportunity. Keep practicing and you'll soon master the art of physics problem solving.